Today we're going to do some maths with you. So we are going to look at this. We're going to look at power rule. What's power rule? So this power rule in derivatives. Yeah, so let's go into it. D of dx just means you're deriving what is coming next. So this is the formula, n is equal to nx n minus 1. I'll explain this to you. This light is always a problem. So I think you can see. So this d over dx, you're going to differentiate x into exponent n is equal to n, which is a coefficient times x into n minus 1. This is a formula. So we are going to take a practical example to show you this. Actually, it's used to find the slope of binomials, functions, and any other function that contains an exponent with a real number. So in other words, it helps to take the derivatives of a variable raised to a power exponent. So the steps involved are, for example, you will have to move the exponent down in front of the variable, multiplied by the coefficient, decrease the exponent by 1. So let's say if n in this formula, I'll show you this. If this n, if n is any real number, then following this formula, let's give an example. For example, x squared, right? So let me write it down. X squared. So x is a variable, is squared, exponent is squared. So let's see how it works. So we're gonna have d over dx. I have to clean this. I think you have seen the formula. I have to clean because I need space. So we're gonna have d over dx. I write and show you. D over dx. This one. Then we're gonna apply to x squared, which is that one. Then this one, I have to put it in this kind of stuff. Yeah, this one. So it's equal to, so you've seen d over dx means I'm going to differentiate what is coming next. What is coming next is x. This is a placeholder. We're going to put a value here and here. So let's say already we know x squared, so it's going to be x according to the formula. Going to be x into 2 minus 1. And then we move 2 in front. We'll move 2 in front. You see here what I've done? This has gone in front, and then I subtracted this with 1. So what is going to be the answer of this? So it's difficult to show this. Sorry guys. This is the coefficient now, x. This is a variable, so we subtract this. So what's going to happen is we're going to have 2x into power 1. Exponent is 1 because we have subtracted 1 from this exponent. And then this one is 1. When you multiply this value out, is going to be only 2x as the solution. You have differentiated this successfully. So this is just as simple as that. You take the exponent in front, you subtract it with 1, and we are done. That's how this thing was derived by Newton and what's the name? Gottfried Wilhelm Leibniz. It's a German. So that's it done, the power rule involving constants. Now let's go to the constants. And in constants, I'm going to write it out again. we have to go first. This is maths. So we have d over dx. So we're gonna have c, which is a constant, to f, which is a function of a placeholder x. Okay, so this is equal to c, which is a constant, d over dx, then into the function, which is f over x. This is what we are differentiating. Okay, so let me show you. D over dx, we are going to differentiate the constant of the function x. So this is equal to constant into what you have differentiate. Now you are differentiating f of x according to this. It's called constant multiple rule. So let's give an example of this formula. You follow the formula. The board is small, so I have to keep cleaning it. Okay. So let's take the example. Derivative of 3x into power 4. According to that formula, which I have shown you, I'm going to have d over dx into 3x to power 4. Okay, so this will be equal to, you see this, I'm differentiating this according to that formula. So this will be equal to 3 over d over dx over dx. Then we're going to differentiate x into 4. X into 4. Okay, so I'm going to differentiate x into 4. It's a continuation of this because there's no space here, so I've shifted it down here. So what will happen is that now 3 will come in front. 3 will come in front. This will be equal to, okay, let me clean this. This will be equal to 3, which comes in front. You shift it down, then multiply times the coefficient, and then reduce the exponent by 1. It will be 3. So you have reduced this one. You have reduced 4 by 1, so it becomes 3. You have moved 3 in front. Yeah. You have moved it. Sorry, 1 minute. Yeah, there was already 3 there, so you moved 4 in front. 3 is there already. We were given this in the equation 3, so we have moved 4 down in front. So we're going to multiply 4 times 3, which will be 12. So this will give you 12 into x into 3 as a solution. X 12, x into 3 as a solution. Yeah. So this is a constant multiple rule. It's called constant multiple rule. And then we're going next. I think that maybe you're familiar with this. That's why I have to move fast. But if you are not familiar, then you need to know something about derivatives, how they work. Now we are going to derivative constant multiple rule. Example, derivative of a constant. So without giving you a lot of details, let's go to it. Let's say dx d. Let's say d over dx. Okay. So this is a constant. We're gonna differentiate this is equal to 0. Why is this so? Because constants are terms that contain only numbers. They don't contain variables. So specifically they are terms without variables. So how do we apply the power rule when there isn't a variable or exponent to bring below? So I'm going to show you the example. This is a formula. Okay, let me just clean this and leave the one in front. So suppose we have u4, sorry, this is 4. I write it looks like u, this is 4. I guess you are seeing it. And then this is a constant because there's no variable, there's no exponent. So we're gonna have d over dx. This thing, by the way, means differentiate what is coming next. And differentiation is just finding the slope of a function. Okay, So yeah, so this one into, I'm just showing you the example, 4 into x to raise to 0. Yeah, because you see 0, a constant is a 0, so we have created x actually, because when you differentiate x is just like 1. It doesn't make a lot of difference. So we're gonna have d over dx, d over dx into 4x into 0. Okay, so this will give you 0, because you have to bring the 0 in front of this, of the 4x, so you multiply times 4. So when you do that, then here is 0, you have to minus 1 according to power rule. So what will this one give you? It's gonna give you a value which is 0 to x raised power negative 1. X is, in this case, is 4, right? And the 4 times 0 is 0. Anything raised to this 0 times x raised power 1. This one is 0, because when you multiply anything by 0, it becomes 0. So you have proved out a constant is always 0, because it does not have an exponent, it doesn't have a variable, right? So we don't have to show this when we are doing this, because we know that the constant is 0, so we normally ignore, we just write 0. Yeah, man. So we can have several examples. For example, we want to calculate, I gave you for any value, you can put any value for practice sake. You can put, for example, 5 and then x into 2, for example. This is just an example I'm giving you. Then you can differentiate this. It's very simple. What you do, you write it like this, you are differentiating this value. So what you do is that you bring down, here is an example, you bring this in front and multiply it by the coefficient. This is a coefficient, okay? So what will be the answer to this? The prime of this will be 2 into 5, and then x, you have to subtract 2 minus 1. X minus 2 minus 1 according to the power rule. So 2 minus 1 is 1, and the 1, x raised power 1 is x, and 5 multiplied times 2 is 10. So it will be 10 into x. Yeah, this one is 1 is just like, you can ignore it, write 10x. This is a solution. You can do several of these kind of examples. I'll give you another one. Maybe I'll give you something like d over dx, and then square root of 2. We differentiate this like this. For example, this is a radical number, so we're gonna differentiate this one. So what do you do? Whenever there's nothing here, no, this I think I should put around maybe 4, and then on this one we'll put 2. Okay, so this will come on top, right? Now I think this one will just complicate the thing. I'll do this in the next video. We'll continue the series. So for now, you just practice these values. You can put any value like d over dx. You can put, for example, 2x to 3 like this. To differentiate this, you'll have to bring this in front here and reduce this by 1. So it will be 3 into 2, and the x, 3 you less 1, like that. Then this will be 6 into x into 2. This will be the solution. You can give yourself practice, like just following the formula. You can put n value like this, and then you can calculate. That's how the power rule works. It's so simple, nothing complicated. I'll continue this series in the next episode, and then we'll see. For those who like maths or love maths, at least we're gonna give it something good. Okay, thank you for watching, and hope to see you again in the next episode. I've started this series on maths, differentiation, and we're going to integral and so on. Okay guys, share, like, and comment. Thanks for watching. The series continues. Bye.